All right, so picking up where we left off, talked about partitions. So partitions increase the throughput of a topic by sharding it across different servers. And basically it takes it and it fragments it, gives us more throughput. Messages can be partitioned by a unique key or automatically by a timestamp. Basically, we could pick to say, hey, organize partitions by state, by business unit, something like that, right? And so all of the messages for a specific state, like for Oklahoma, would all be in partition 1, and then California in 2, and Nevada in 3, right? And so on and so forth. And that would make it easier to find the data you wanted, so you'd only have to look at one partition. Almost all of these products can do it automatically for us by when the message is received, and it just what's called round robins the data. And it saves one message to 1, the next one to 2, 3, and then so on and so forth, right? And rotates through them constantly and manages that automatically. But either way, partitions just increase throughput. So what is a message? It is the actual payload sent by a producer and put on a topic. So a message is the actual information or data sent by whatever system is sending it. A message can be read 0 or many times, and message brokers are different from message queues in this way. So again, multiple people can read a message, and they can read it many times as they want. A message queue allows one consumer to read a message one time, then destroys it. A broker doesn't do this. Consumers track their offset or their place in the topic. Each message has a unique offset, which increases continuously. So basically, you just have to remember, if I'm reading through this, what message did I leave off on, right? Did I leave off on message 10, on message 20, 50, 100? And that's called your offset. It's kind of like your page number in a book, right? These solutions, these message brokers don't remember where you were. They don't remember what page you were on. You have to track that yourself, right? And so whenever you go looking and you say, all right, I left off at message number 500, and so now I need to read 501, 2, 3, 4, 5, right, and so on and so forth to get to the end. And so again, your offset is kind of like a page number, and it's just what message have you read last in that partition, right? So you know to pick up from where you left off. And so brokers don't track your offset because they don't know how many people are going to try to consume messages, right? That would be a lot of information for them to manage if a lot of people come and try to read continuously. So because messages are not deleted when they're read, and because many different applications could be consuming the same data, Event Hubs doesn't track what messages, who has read. It doesn't track that you read the 500th message, right? This means every consumer has to keep track of what messages it has and has not read in a topic and in a partition. And so that's called your offset. Your place in a partition is your offset, and it's like a page number. It's just what messages have you read and what messages have you not read, and that's your place. That's your offset. So an offset is like a primary key in a database. It's just the unique number. A primary key is usually a unique number for every row in a database. Every row in a database has a primary key for tables that have a PK assigned at least. Every message or payload has an offset number. Every offset is unique, and this offset increases monotonically. That means it just continuously increases from 0. So the very first message is 0. The second message is 1, 2, 3, 4, 5, and so on. And every message has an offset, and every one of them is unique, and they all continuously increase. So an offset is how messages are accessed. They act as your place in the topic, like a page number in a book. That's right. So here, if I was in the 20th partition and I was at the 50th offset here, whatever that is, right? I'd know there are a bunch of messages after. And if I read them all, I would read all these, and then I'd increase my offset to this one here at the end, and some new ones would come in, and I'd come back and I'd read those up to the end, right? And so on and so forth. So a streaming data pipeline, a sample pipeline. So what technologies would we use to stream and to process streaming data, right? And so we have a producer, an IoT device, and this could be a drilling rig. It could be a completion crew. It could be an engine, a car, an Apple Watch, whatever, something that generates data and sends data to the cloud. This was a message broker. This is the product that captures the data generated by our IoT device. So our IoT device sends data to the cloud. It sends it to Event Hubs. Then we have a stream processor. So Event Hubs just stores the data. Something actually has to come retrieve the data and do something with it, process it, move it, filter it, parse it, do something. and send it somewhere. So in this case, it could be Power BI. And so we could send data from an IoT device or from a website like Twitter to event hubs, and then pick it up off of event hubs and do some kind of basic analysis, and then visualize it in something like Power BI. So in practice, there would be many producers, possibly tens or hundreds of thousands of producers, and the data from the broker or processor could be stored for bulk analytics. So we could also capture it over here, right, and say, I'm going to run Stream Analytics to pick it up off of Event Hub and to process it, but I could also store it, so that way I could do a large query using something like Spark later if I wanted. So data in Event Hubs is kept for 1 or 7 days, depending on the version being used, so I can configure how long the data is kept in Event Hubs. And they have a standard and a premium offering. Premium is, as you would expect, more expensive, but it allows for more features. It allows for data to be kept longer, and it allows for more throughput of data. Data can also be stored in Azure Blob Storage, which, if you remember, is like AWS S3 or Azure Data Lake for bulk analytics. This data, when stored, is automatically partitioned by timestamp into folders. So basically, it organizes the data by time, right? And makes nested folders. That way, we could store months or years worth of data. We could have hundreds or millions of files, and that way it keeps it organized for us, right? So Event Hubs is modeled on a solution called Apache Kafka. So we talked about some Apache solutions, and Apache is just the open source software foundation. So they just create open source software. Apache Kafka was created by LinkedIn, and it stores all of the events from their website. So like we've already talked about, websites like Facebook, like Google, like LinkedIn, like YouTube, they capture all of the information about what you as a user do, right? So what do you click? What pages are you on? How long are you on there? What'd you scroll? What'd you highlight, right? All of that data is captured and analyzed, and that's how Facebook and other companies continuously improve their algorithms and their user experiences by knowing what people do, for how long, and where. And so they can figure out the user experience that maximizes engagement in their terms, right? And they can also assess the effectiveness of advertising, which is how they monetize their services usually, right? And so anyway, LinkedIn captures all this data, and they have thousands and thousands of web servers which are generating this data, right? It's not just one big machine running their website, it's thousands and thousands of machines running their website. And so they have to capture data from all of these thousands of machines and analyze it, and so they use Kafka for that, which is a publish subscribe message broker, just like Event Hubs. And so all of these web servers send their information about what users are doing to Kafka, and then people can come and access that data to do an analysis or look for suspicious behavior or things like that. And so that broker is one place for people to come to get the data, like what we've already talked about, right? So LinkedIn created it because they needed something to serve that function. LinkedIn, in some cases, has Kafka never age messages out, so consumers can come in and see all the events in a topic since its creation. So what that means is, I talked about how by default, things like Event Hubs age messages out after about 7 days. Well, LinkedIn created and runs Kafka, and so they can set it to never age things out, and it just means they need more storage space. But what that allows people to do is go back and see all of the activity that was captured ever since the topic was created, right? And go back and replay every event that happened for whatever that topic was, right? Whether it was people's LinkedIn requests or their resume updates or whatever they captured. They could go back and look and reconstruct, point-in-time snapshots of that data by going back and replaying all of those events that they've captured and never delete. So this means they optionally don't have to store that data in a database. Kafka could become the source, and this is what's called a Kappa architecture, where you just go back and you replay all of the streaming events in order to understand your state. This isn't frequently used because it's very time consuming and very expensive, and you have to go back all the way to the beginning. And so if you have billions of events, you have to read all of those billions of events in order to make sure you haven't missed anything, which is not exactly tremendously efficient, but it can be very useful for some use cases. Especially to get point-in-time snapshots, it'd be pretty useful for that, because you could read from the beginning up to the point in time you wanted to know, right? And that can be kind of difficult or impossible to do with a database, just because of the way they work. So stream analytics. So Event Hubs doesn't actually do anything with the data. It's just a repository. So like we saw here, IoT sends the data to Event Hubs, but Event Hubs is just storage. It just takes the messages and it stores them. And so stream analytics, so Event Hubs doesn't go retrieve the data, somebody pushes the data to it, and it doesn't push the data to anybody. Somebody has to come pull the data and process it. And so Event Hubs is just a repository that's an intermediary. So somebody pushes the data to it and somebody pulls the data off of it. And so Stream Analytics is one product, one of many, that can actually go out and pull data off of Event Hubs and process it and send it other places. So Stream Analytics consumes the data from Event Hub or IoT Hub. It can transform the stream, look for patterns, or enrich the data by looking up values in Blob or SQL. So we frequently, like at Devon with our digital security logs, which we get about all of the different servers, they include like a user ID. Well, what if instead of the ID we want the person's name? So we have to look up the user's name or the computer's name from an ID that's in the log file. That's enrichment, and so we would use something like Stream Analytics to say, for each of these log files, look up this number in a database and add a new field for username, right? Look up the user ID in our database, add the username to the stream. Stream Analytics can do that. It can merge multiple data sources together to enrich the final data set, which the idea would be obviously that would make our analysis more robust or make our search more relevant, right? If we were searching by username, we wouldn't have to know their user ID. That'd already be in the dashboard or data stream. So Stream Analytics uses a SQL-like language to perform operations, making it fairly easy to work with. So we don't have to learn some new coding language. We can just write SQL. So Stream Analytics can push data to many downstream services for storage and visualization. So you see here, this is a diagram kind of like the one that I had, right? Where we can have applications, and these applications would be like the LinkedIn website, the Facebook website, right? I talked about how those are capturing data and sending it to something like Event Hub. We could have a whole bunch of things like an Apple Watch, a phone, a Wi-Fi device, and they could send the data to IoT Hub or Event Hub, you see here. And so IoT Hub is just a different product in Azure. And it has more features than Event Hubs, but it's also more expensive. And IoT Hub can actually manage these devices, and Event Hub doesn't, right? Event Hub just receives messages. IoT Hub can actually go out and it can manage the endpoint and do things like updates or push machine learning models or the like. Stream Analytics can read from both of these. It can read from Event Hub's IoT Hub or Azure Blob Storage, which again is like which is like AWS S3. And then Azure has a machine learning service that can plug into, and there are a number of other things that are not pictured that can plug in and feed into Stream Analytics. But then it can push the data back out to Blob Storage or to the data lake. It can put it on a bus, or it can basically plug into a custom piece of code. That's what all these are. So Azure Functions are custom code that people have written to do things, or it can send it to another Event Hub. Right, so I could process the data, I could enrich it, I could apply a machine learning algorithm, and then I could put it on Event Hub for other people to come consume, right? And that's frequent, that's commonly done. Or I can push it to Power BI, right? And so there are a number of ways. So Stream Analytics is like the engine, right? It takes the data, it processes the data, and it moves the data. It's the processing engine for this pipeline. So Stream Analytics can perform windowing aggregations and calculations on data as it streams in. Common window functions include tumbling, sliding, hopping. Each of these are useful depending on the use case, so depending on what you're trying to do. So windowing is used as a group by clause in Stream Analytics. So in SQL, you remember we did group by, where maybe we did group by year or group by state or something like that. If we want to, maybe sum all of the events in that events table by country, that'd be a group by clause. And so a window is the same way. So a window is a group by, and it's just for time periods, right? So you see here, time 1, 2, and 3. These are just points in time. They could be minutes, seconds, hours, whatever time window we're using. And so we're just grouping the first 3 hours together maybe, and then the next 3 hours, and the next 3 hours, and so on and so forth, and outputting events here. So you can see here we're just adding these up, right? And we're outputting a number, and we're adding these up, and we're outputting a number, and we're adding these up, and outputting a number for each time step. And so that is a tumbling window. So tumbling windows have intervals that don't overlap. results are returned at the end of each window, and events can only belong to one window. So basically here you can see I have 10 time steps. So I'm selecting time zone. I'm counting all of the entries here as count for my Twitter stream, defining my timestamp, and I'm grouping by time zone and tumbling window. And here it's doing every 10 seconds. So I've got a window every 10 seconds. So the first 10 seconds, and it counts up how many events I got. And then the next 10 seconds, and it counts up how many events I got. And the next 10 seconds, and so this is a tumbling window because it looks at 10 seconds and I get a result. And then I wait 10 seconds and I get a result. And then I wait 10 seconds and I get a result, right? So I'm getting one number every 10 seconds from my event. I'm not getting constant numbers. This isn't streaming like a graph that streams constantly, right? I only get an answer every 10 seconds for the things that happened over the last 10 seconds. A hopping window would give me answers every 5 seconds. And so this would basically say every 5 seconds, give me the count of tweets over the last 10 seconds. So I start it up, I wait 10 seconds, I get an answer. But then 5 seconds later, I get an answer. 5 seconds later, I get an answer. 5 seconds later, I get an answer. And so this hopping window basically looks at overlapping intervals. You see here, some of these will be counted twice, right? And so it looks at this set of data, and it hops, and basically every 5 seconds I get a new answer, and it looks at the last 10 seconds. And so this really just solves a different problem of the tumbling window. The tumbling window, I know my data will only ever be counted once. I don't get answers that frequently, right? This one I get answers more frequently, but I also will get some double counting, right? Which may or may not be a problem depending on the question I'm trying to answer. And then sliding window just updates. It produces output when an event occurs, and events can be in many windows, and the window will always increment. So this basically means I'll get an answer every time something happens. And so if I say, give me a count of tweets for all topics, which are tweeted more than 10 times in the last 10 seconds. So basically, as soon as I get a tweet, I get an answer, right? You've had 1. And then I get another one, you've had 6 in the last 10 seconds, right? I've had 3 in the last 10 seconds. And then it waits, nothing happens, and then an 8 comes in, and I get an answer there, right? And so every time a tweet comes in, I get an updated count of tweets for the last 10 seconds. And so I could have the same tweet in multiple windows here, but basically this output, this result, this dashboard would update constantly. And I would constantly just get an update every time a tweet came in for how many I got in the last 10 seconds. And so a tumbling window, nothing's going to be double counted. I'm only going to get an answer every 10 seconds, and it's just going to tell me the count for the last 10 seconds. A hopping window overlaps. This is how far back it looks, and this is how often it tells me. It looks 10 seconds back, and it tells me every 5 seconds. And then a sliding window basically says, look 10 seconds back, and it's going to give me an answer every time something comes in. Every time something comes in, it's going to say, what's the count for the last 10 seconds? It's 1. What's the count for the last 10 seconds? It's 6. What's the count for the last 10 seconds, right? It's 15. Count for the last 10 seconds is 8, right? And so I'm going to get these answers every time an event comes in. All right, so the final piece of technology on this tool chain, right, is Power BI. So Power BI is Microsoft's visualization tool. So we looked at QuickSight briefly, right? This is Microsoft's competitor to QuickSight, or in reality, Power BI came first, so QuickSight is Amazon's competitor to Power BI. Power BI is Microsoft's visualization tool. It includes a desktop and web-based component, and so I can use a web browser to generate Power BI reports, or I can install it on my desktop and use that. They both interact together. I can build something on my desktop and push it to the website if I want for people to consume. So web-based Power BI is capable of displaying data that auto-refreshes. Basically, it can display streaming data. So this means data can be pushed from an API, again, an application programming interface, Stream Analytics, or PubNub, a streaming data company. And so I can visualize data from a few different streaming sources, basically what this means, in Power BI, and it'll constantly refresh my visualization. So sensor management. All right, so kind of going back to the IoT Hub side of that, right? So I talked about this tool chain, about these things. So I talked about all of these technologies, right? I talked about what would produce, Event Hub, Stream Analytics, and Power BI. But I mentioned that there's another service down here called IoT Hub that's analogous. It's a similar offering to Event Hubs, And so I'm going to talk a little bit about why those two exist. So the other part of the IoT challenge is maintaining endpoints or sensors. And I talked about this a little bit, but if I have a sensor out either at a cash register or at a field site, I may want to update it. I may want to deploy custom code to it. I may want to build and put a machine learning model on it, or I may just want to know information about what's connected to it, right? And so in order to capture that information, in order to manage that sensor, like manage its ability to send me messages, I would need something like IoT Hub, right? So Event Hubs, Kafka, and Kinesis. Kinesis is AWS's version of Kafka. And so Event Hubs, so Azure has Event Hubs for Publish, Subscribe, Message Broker. AWS has Kinesis. Event Hubs and Kinesis are both PaaS services, and they would be competitors to one another. So if you're on AWS, you would use Kinesis. If you're on Azure, you'd use Event Hubs. They both do the same thing. These collect data, but they don't track anything about the publishers or consumers. So if you look in Event Hub, it does not tell you anything about who published that message. I don't know anything about the publisher, right? It doesn't say this person from this store sent this message and it has this sensor with this version. Event Hubs does not know that. Event Hubs just does not care. It says, hey, I got this message at this time with this offset, right? And here's the contents. So Azure IoT Hub offers more functionality for endpoint management. IoT Hub lets me manage those sensors, and it also lets me set usernames and passwords on those sensors to manage who can send me data, basically. So IoT Hub is more expensive than Event Hub because of these additional features. So IoT Hub can communicate bidirectionally with my sensors. So I said that Event Hub does not send data. Event Hub only captures data. It does not send data to my sensors. IoT Hub can both receive and send data to my sensors. So sending messages or commands lets me update the sensors, so I can have IoT Hub tell my sensors what to do. Frequently, this is used to control what data the sensor sends, how frequently it sends it, and if any calculations are done. And so, like I talked about, at some of these sites, like some of these remote field sites or things with limited compute and storage capacity, I don't actually send back all of the data that's captured. Like airplanes don't send in real time all that 500 gigabytes of data. They only send a subset of that data back, right? They send the data that's important because if you're on an international flight over the ocean, sending back 500 gigabytes may be kind of difficult, right? To a satellite uplink or something like that, and it would be very expensive. And so what these companies do is they send back critical information, right? And try to conserve the bandwidth of their connection. And so if you realized, well, now I want a different piece of data because my data scientists built a model and they realized that a different sensor reading is very predictive of engine failure, you don't want to have to go and touch every airplane or every field site or every cash register to get this new data set now, right? Or to send it more frequently or to send it less frequently. You would use something like IoT Hub and tell all of the sensors, hey, now I need you to capture engine rotation on a 5-second basis, right? Tell me the average engine rotation speed for the last 5 seconds, right? And you could use IoT Hub to change that setting on all the sensors. Or maybe you realize that you're capturing a piece of data that's not very relevant, or you're getting it every 1 second, where every 10 seconds would be sufficient and save you some bandwidth and money. You could have IoT Hub change that setting too. And so frequently IoT Hub is used to configure what data is sent from the sensors and how frequently, and do they send you the average, the mean, the median, the standard deviation, like what kind of calculations do they do on the data before sending it to you, right? And it can be used to push machine learning models to the edge or manage other software. Yep. So I got 2 of those. 3 of those. All right, so digital twins, so device twins. So some sensors can be offline for days or weeks. So like wind turbines, they don't necessarily need to check in all the time, maybe. And so they just check in every few hours or maybe even every few days and send some basic diagnostics maybe and look for updates, right? And so digital twins or device twins are information stored in the cloud about the sensors and devices out there in the field. And so if one of my analysts wanted to know, what are all of the versions of our wind turbines that are currently in use, but our wind turbines only come and actually send or receive data every week. I would obviously want a repository of that information, right? I would want a digital twin that allowed me to go out and run queries about, hey, these are all the turbines, these are all the versions, these are all the locations, and maybe some basic information about their operation characteristics. And so that I would use that repository would be my device twin repository. So that would be a repository of information stored in the cloud about all of the physical assets that I have and about their sensors, versions, and any other relevant information. So these are used to get information about all of the deployed devices quickly. Some companies like GE also use digital twins to perform simulations in order to predict part failure on specific engines or turbines. And so if my digital twin knows the basic mechanical information, software information, and operating characteristics, I can actually create a model and subject that digital version of my asset to different scenarios, right? And so what if the wind was above a certain speed, right, above so many 70 miles an hour, and I know some basic information about my turbine. What's the likelihood that one of the blades would fail, right, or that the motor would overheat? And so we can develop models and use the information we know from the digital twin to run different scenarios, right, to help us to make predictions and do things like plan maintenance or outages or things like that. And so GE does have used their digital twins to perform simulations and run different tests. In IoT Hub, device twins are created per sensor and device, and the parameters captured can be configured. And so basically IoT Hub does create this digital twin or device twin, and I can tell IoT Hub what I want to know about my device. Device twins are updated every time a device connects, and this data is stored as JSON, which we talked a little bit about, but it's basically just a very flexible format. It's a very flexible payload because obviously a lot of different companies in a lot of different industries might use IoT Hub, and you would capture significantly different things about a tank battery or a pumping station than you would about an airplane, car, or a wind turbine, right? And so Microsoft has made this solution very flexible so different companies can configure it to their unique industry and needs. So device identities, every device or sensor has a unique identity, so it's got a unique number, a globally unique identifier. This allows them to be individually managed, monitored, and retired. And so every wind turbine, every engine, every sensor gets a unique identifier in IoT Hub, and that way if somebody sells the jet engine or goes off contract and I'm no longer interested in it, right, because I'm no longer managing it, I would be able to retire its identity so that I no longer received information from it. Or if a cash register got sold or otherwise, even stolen, I would want to retire that device identity and so that updates were not pushed to me from that piece of equipment. And I would do that using IoT Hub and each of its device identity. Frequently, the devices are issued long machine-generated passwords or certificates. These must be unique to each device so they can be revoked. And so basically, it makes it easier to manage my devices because if I don't, I have to have some other mechanism like putting a username, password, or certificate, which is just like a long string of machine information. And as soon as I want to retire one of those, right, because I sold a store or a franchise or something like that, I have to go and revoke all those username and passwords, or I have to revoke all the certificates, and it's manual and tedious, right, and it can be error prone, and open the company up to malicious individuals overwhelming their systems with junk data, right? So IoT Hub is a PaaS service and primarily charges based on communication volume. So how many messages am I receiving? IoT Hub charges me for the number of messages. A multitude of different devices can be connected to IoT Hub, including custom controllers, Raspberry Pis, and Arduinos. And IoT Hub supports common protocols for device messaging, namely MQTT, which is a lightweight protocol for edge devices. So we talked about AMQP and HTTP. They're just languages for sending data. MQTT is a very stripped down protocol or language for sending data. And so it's the default for IoT Hub just because it's, again, it's a very lightweight protocol or language, and it's very efficient. And finally, Azure provides a tool for visualizing and analyzing time series data. So time series analytics allows for plotting and comparing temporal data. So visualizations and analyses for time series data can be a little bit different than for other data types, just because if I'm looking at like rows in a database about customers, one customer is not necessarily related to the customer before or after them, right? They're just rows in a database. One could be from Oklahoma, one could be from California, completely different occupations, completely different types of customers. So things like customer records are not related to the one before or after. But time series data obviously is. The sensor reading 1 or 2 minutes before the one I'm looking at and the 1 or 2 minutes after they're connected, right? One came before the other, and I want to understand the relationship between them. And so time series data is connected, obviously, across time in a way that other data types are not, which makes plotting them. They're commonly used things like line charts, obviously, but you can get fairly sophisticated with the interactions there, and with heat maps and things like that. That may not be as well supported in all tools. And time series insights is designed to be tailored for visualizing, charting, and analyzing temporal data, basically. And so time series analytics allows for plotting and comparing temporal data. It also provides options for aggregating and selecting custom windows, like we talked about with the sliding, tumbling type windows. Time series analytics can store data for a configurable number of days, and queries are fairly simple, and the tool performs basic stats. And so I could take data and load it from a stream analytics or from an event hub, and use time series analytics to do longer range queries or look for trends and things like that across a range of days. And so this is a good bulk analysis tool to visualize large quantities of time series data, basically, from my sensors. So I talked a little bit about AWS Kinesis, but it serves a similar function to Event Hubs, and so it is Amazon's version of Event Hubs. Kinesis can collect vast quantities of data. It uses shards to partition the data across an environment for higher throughput, and it is a message broker. So Event Hubs has partitions, Kinesis has shards. They both increase throughput. Kinesis has two offerings, Streams and Firehose. So Streams is the original. Streams has been around for several years. It's very bare bones, but supports a very high throughput at a very low cost. So Streams is the original vanilla version, and it's exactly like Event Hubs. Firehose scales or shards automatically, and in Event Hubs and Kinesis Streams, this has to be done manually. And so if I realize that, hey, I've got 4 shards or partitions, and I really need 8 because I've gotten a lot more stores that have come online. They're sending me a lot more data, and now I'm starting to get backed up just because I can't handle the volume of data now. I would actually have to go into Event Hubs or Kinesis and manually adjust that, which might be a problem because I may not realize I'm missing events for a while, right? And then that data would be lost. AWS Firehose automatically scales or shards, which allows it to dynamically respond to increases or decreases in traffic, right? So if I get more or fewer messages, I can have this product automatically scale up and down. Firehose allows me to export directly from the stream to S3 or Redshift without using another service. So like I talked about with Event Hubs, to get the data into another product, I would have to use Stream. I would have to use something to pull it off, right? Firehose basically has that built in, right? And so Firehose can not only receive the data, but it can also move or manipulate the data. And then this is unlike Event Hubs, which must use Stream Analytics or Kinesis streams, which must use a separate Firehose instance to move the data. And so Firehose is really like two products in one, right? It's like Event Hubs plus Stream Analytics, or it's like Kinesis streams plus some other third-party solution to both store and move the data. And so that's it for this video. I'll upload one more where we'll close out the slide deck. We'll close out the presentation.